All right. Hey guys, today we're going to be looking at find peak element. It's one of the most important questions that will teach us how to use binary search and implement that method to solve similar problems, right? And so today's problem is pretty straightforward. However, the implementation uh, is a little intuitive, but while writing the code, you would sense that we are almost trying to write uh, a variation of binary search. So let's go through the question first and see what it says. So given an array of integers in which the elements monotonically increase from the first element to a of k and then monotonically decreases from a of k plus 1 to the last element of the array, thus creating a heap of numbers, right? And so what we need to return is return the index of the peak element, right? So we need to return the index of the peak element. That's a goal, right? So let's try to understand what the question actually is presenting us with. So it's saying, let's assume there's a list of numbers that you have, right? And let's assume we've got our array A equals let's say we have 0, 1, 2, and 3. So far it's increasing. Let's start to add numbers in decreasing order now. And now we have 0, 1, 2, 3, 2, 1, 0. Right? In this case, intuitively enough, we should be returning the index of the peak element. And as we can see, it's very evident that 3 is the peak element, and the index of the peak element is 0, 1, 2, 3. 3. Now this could have been -1 as well. The question does not say that they're equally increasing or equally spaced. They're just saying the elements are first increasing, and then until a certain element they monotonically increase, but after that element they start decreasing. And we also can assume that there will only be one peak. So once they start decreasing, there never will be a case again where you see them increase again, right? And so you can think of it like a mountain or a pyramid, or you could say the peak of the triangle, where you say, okay, I have let's say in order for us to understand this array, let's say 3 is at the peak. All the numbers to the left, right, are 2, and then we have 1, a bit tricky here, we have -1, okay? And all the elements towards its right are decreasing as well, right? We have 2, we have 1, my bad, it's 1, and it's 0, right? Okay, let's see. Yeah, so this is what we have in a question, and then we need to return 3, right? Now think about it this way. If we try to apply a condition here where every time we try to shrink our search space, right, and then every time we see that if our middle element is greater than the next element, so what made us think that the middle element, when greater than the next element, would yield us the result? Now let's look at it. It's pretty simple. 3 is the only element which satisfies this condition, which is the maximum element, right? And so 2 is also the element that satisfies this condition, but it's not the only maximum element that satisfies this condition. And then 1 also satisfies this condition because the next element after 1 is indeed smaller than it. So 1 satisfies it, 2 satisfies it, 3 satisfies it, and then this 2 does not satisfy it because the next element is greater than 2. And as soon as we hit this point, we now have our solution. we don't have to go any further, right? Because this condition has failed. Now, and so the intuition again here is to move towards the left of the array, as we did with the previous questions, where we always try to move towards the left of the array, left in the array probably. If we found a satisfying condition, right? And this has been our intuition, and this has been our condition, right? And so let's try to implement this using simple binary search. Well, once I started typing out Python code, I forgot this is JavaScript. So in JavaScript, we just call this the function definition with and proceed it with a function keyword, and then we say peak of array. We can pass in the array, and now that we have our array, we need to do the simple binary search here. We say let left is 0, right is array length -1, right? And then let peak index, that's our result that we are looking for, be set to -1. So in cases where we don't find the element, we just return -1. And now we start our traditional classic while loop for binary search. We say, okay, initially we have got a full search space, which is the full array, and then every iteration we try to find the middle element. We say left plus math dot truncate, which is trunk in JavaScript, right minus left over 2, right? Just a small recap. Right minus left over 2 is going to give you a floating point number. Trunk is going to give you the integer equivalent of it, and then left is going to accommodate the decimal part of it to get you to the right middle element. And we are using this non-integer overflow method, where it's always guaranteed that we'll never never hit the overflow exception, right? And now that we have our middle index, let's see if we are able to write out our condition that we have decided on, which is middle element greater than the next element, right? Because it's evident that as soon as the element is greater than the next element, it could potentially be our peak, but we are not sure, so we're going to continue the iteration. So we say array of mid, right? If it is greater than array of mid plus 1, right, which is the next element, then we know for sure that our peak element could be potentially this element. And so we just set our peak index to the middle index, because that's where the middle element sits. And then we need to shrink our search space and truncate it from the right. So we move our right pointer to mid -1, right? Else we just say that left is mid plus 1, right? If that condition is not satisfied, then we say, okay, there's still a element that's to the right which could satisfy our condition, so let's move towards the right in the array. And so we move towards the right. This is trying to move to the right in the array, and this is trying to move towards the left. All right, and eventually we need to return peak index. So a little different from the vanilla binary search. All we did was use our simple intuition and converted it into a decision here, a condition, and kept updating our result, but we still continued to do further iterations down the line, right? I would say let's try and run it and see what problems we face this time, right? I know we don't usually run our code, assuming that we are in an interview setting and we only use test cases to walk through our code. However, let's try to run it this time, see what problems we face, right? Now, before running it though, let me call this function with some test cases. Let's assume, let's copy this initial array, and we know that the function should be returning 3 as the index, which is this one, right? Let's see if it does that, right? Save it, run in debug mode. Let's run node.js. So it says true, so it worked, right? Okay, so why did it work, right? It worked for 2 reasons. You may have noticed that we have array mid plus 1. So we are never going to go past the last element, because every time the mid element is going to fall within the boundaries. So we are never going to overflow. We are never going to go past the array length. That's 100%. And then the second thing that's guaranteed here is that if the peak index is not found, that is, if this condition is never hit, then we end up returning -1. So let's see if, let's assume this was 1, 2, 2, 2, 2, 2. So there's no peak at all. And so this should return -1. Let's see if our logic works here. Okay, it returned -1. As you can see, the output is true. It returned -1, and our logic works here. Okay. Since there's no peak, we're gonna return -1. Yeah, so this was it. This was the basic implementation of binary search, where the array is implicitly sorted, but it's not sorted in a traditional way that we would expect an array to be in. For example, it's not all in increasing order, it's not all in decreasing order. There is a small glitch in between, which is the peak element, and we just want to return the index of the peak element here. And so this was it. We'll go through a couple of more binary search questions in the next couple of videos. Looking forward to it, really excited. Thank you and bye-bye.